Hi guys, in my previous class I gave some introduction about vectors. So vectors are physical representation or diagrammatical representation for a given physical quantity. So of velocity, force, acceleration, these all are vectors. Vectors represented with an arrow. The length of the arrow represents its magnitude and the direction represents in which direction it is moving. So today's class I would like to talk about how we can add vectors. So ask a question, what is similar about these two vectors? Are these two vectors magnitude same? Yeah, their magnitude is same. But what is different in these two vectors? The difference is in its direction. So whenever we add two vectors, we must more careful about its direction. Let's try to add these two vectors. Since they both are in same direction, so that two vectors total sum will become 7 meter. 4 meter plus 3 meter equal to 7 meter, and the resultant direction also same direction. How did it added? Take the first vector and bring the second vector tail to the first vector. So this method is known as head to tail method. The second vector tail should bring to the first vector head. So now it is added. So this is the resultant which gives the 7 meter. Now let's add these two vectors. Now these two vectors are opposite vectors. Now what it could be the resultant? The resultant will be 2 meters. But in which direction? So let us try to add. Take the first vector. The first vector is 6 meters and bring the second vector tail to the first vector. So that is the condition. So second vector tail should bring to the first vector, and which is the leftover. So here small portion is left. So that is the resultant vector. So here the resultant vector is 2 meters. Now let's take some random direction. So here LBS is a force unit. Suppose the green vector is showing some arbitrary direction and yellow vector is showing another arbitrary direction. Let us add these two vectors. How it becomes 5 ellipse. So this is also you can add by head to tail method. Take the first vector and bring the second vector tail to the first vector. Now draw a resultant vector from first vector tail to the second vector head. If it is in a random direction, this is a way to draw the resultant vector. Now how to find the resultant vector magnitude? Now this forms a right triangle, and we know how to calculate the right triangle hypotenuse. So the right triangle hypotenuse equal to, by applying Pythagoras theorem, so here square root of 5 square plus 3 square plus 4 square, which gives the 25 under root, which gives 5. So this is also known as a triangle law. Let us apply to this realistic situation. Suppose two forces. One force, 4 ellipse, is acting on this ice peak in one direction, and another force is acting another direction. And where it could be the resultant force acts, it means finally it will go in which direction. So we should add these two vectors. In the previous example, the first vector head and second vector tail should join, and they become to get the resultant vector. And this is also known as triangular method. The same head to tail method for two different vectors, or we can add this another method known as parallelogram. So in the diagonal method we use the same head to tail method. So this method is also known as triangular method. Triangular method for two different vectors. So other than this method, we can use one more method other than the head to tail method. So that is known as parallelogram law vectors. Suppose try to add these two vectors. So in this case, we were using parallelogram method. So little change is there. In parallelogram method, we don't add head to tail. So no head to tail. We don't add like this. So how we can add? So take the first vector and now bring the second vector tail to the first vector. Now these two vectors becomes two sides of a parallelogram. Now how to find the resultant? So we can find the resultant by taking exactly two another opposite sides. Since in parallelogram opposite sides are same, so if these two vectors are represents two sides of a parallelogram, then the resultant vector represent the diagonal of the parallelogram. So the diagonal of parallelogram also can be calculated by using same Pythagoras theorem. So this method we known as parallelogram of vector addition. Now let us try to add three different vectors. Any method you can use, either the head to tail method. So that is easy. Now how it is added for more than two vectors? As usual, first we take the first vector and bring vector second into the same direction to the head to tail, and now you can find the resultant vector. So now the third vector brought to the second vector. Now the third vector is represented. And where is the resultant vector? So this is the resultant vector. And if you can change, instead of adding in order, suppose if you take this A and B and C. So here I added A plus of B plus C. So this is the order I added. So this is the first one, second one and third one. So in another case, we can add some another case. So first as taken A, and this is A vector, and now this is C vector, and this is B vector. Now if we get the resultant as is it is same, yeah, the resultant vector is also same. So because even though if we can change the order of the vectors, but the resultant is same. So how it is same? Because vectors, they follow law of association. So that is, you can write that, we know that A plus of B plus C which equal to A plus B of plus C. So this is known in mathematics known as associative law. Not only that, if vectors, two vectors, they can follow commutative law of addition, A plus B equal to B plus C. So this is known as commutative law. And this is known as associative law. associative law of addition. Yeah, here we are doing addition only. So if you can change the order of vector addition, but the resultant vector will be same. So this is how, by using two methods. One is head to tail method, and that method is also gives the triangular method, and second one is parallelogram method. So by using these methods we will find the resultant vector. So in this case also, if you can apply the resultant force, in both the cases it will become same. The resultant force will be acts whether you add a vector, b vector, c vector. Let us understand the vectors in the realistic situation. So the situation is like this. Suppose if a train is at rest and you are moving in the train. So what is your velocity? So you can observe your velocity. So that is the velocity of yours. Suppose in the second case, if the train is moving forward and you are moving in the train. So in this case you are having velocity. So this is the velocity of train in the forward direction and your velocity. So in the second case it looks you are moving faster. So let us see the third case. If the train is moving backward and you are moving forward, so what do you observe? So in these two cases, so here you observe you walks like slow, and here you walks like fast, and here just like normal. Try to guess why it is like that. So that I am leaving to you to explain. So this is all about, this is the direction. If your velocity is added to train velocity, what is the resultant velocity? The resultant velocity will becomes maximum. In the second case, if your velocity is forward direction and train velocity is backward direction, what is the resultant case? The resultant case is minimum. And in the first case, train velocity is 0. So you are only having your velocity. So this is the final resultant velocities. Let's try to observe one more time. So this is the realistic case, since velocity is a vector. So we need to consider the directions too also. So if you move with 2 miles per hour in one direction and maybe some wind is acting on you in another direction, let us take that is a wind. So what is your resultant velocity? So your resultant velocity and direction, they both will be changes. So because they both are vectors, we need to add those two vectors to get the resultant. So this is the importance of the vectors. Let us try to apply this in realistic situation. Suppose you are rowing in a calm water. So the water is not moving, the water is at rest. Suppose if you apply force on it, so you will reach straight. So there is no deviation at all. So because the water is at rest. Now let us take a situation. In the river, water is moving with slow moving water, and its direction is also given. So this is the direction, and try to add. Now this is your original direction, and now water direction is also come up in the picture. Now if you do that, now this case you notice there is a change in the direction. Why? Because at here two vectors are acting. So one is your velocity, so this is your original velocity which you want to go, and but this is the river velocity. If we can add these two vectors, obviously we will get the resultant. So that's the reason our direction of destination will changes. So being a rower, so you need to know about that. Now let us understand what happens if water moves fast. Now here you can see the magnitude of the river water is very big. Now if you want to row in the straight, will you reach the straight destination? Obviously no. So now here you can see your velocity will be changed and the direction of the destination also will be changed. So that is happened due to because of river water velocity. So these two vectors are add up. That is added by the triangular method. So that will lead to the resultant. So whenever comes to realistic situations, try to apply this knowledge. So if you are rowing 4 meters per hour towards to the west direction, and if the river water is in north direction, so if this is directions, so you are moving in west direction, you are moving in west direction, and the river water in south direction. So because of these two directions, where is the resultant directions? Yeah, resultant direction is somewhere here. This we call southwest or west southwest. You can call this direction as southwest. So these things we should be more careful, especially when we are just like rowing in the water or the motion an aeroplane. So the magnitude and direction can find out. Here the magnitude can be find out by using the triangle law, by using Pythagoras theorem, and direction can be resultant vector direction. So the resultant vector here 5 miles per hour. So apply the same situation to an aeroplane. Suppose this is the velocity of the aeroplane which is moving in the straight direction towards to the north direction. So let me take the directions one more time at here. So these are my directions. So north, east, west, south. Plane is moving towards to north. But if there is a wind is blowing towards to east. Now because of wind, will the plane velocity and direction changes? Yeah, obviously the plane velocity and wind, the plane velocity changes and the wind direction also changes. Plane direction also changes, because the two vectors they are supposed to add it here. So that gives the resultant. I hope you got meaning it here. So let us take a situation what happens if there is more wind. So by the time it is very difficult to handle it also. So now the plane speed is increasing more and its obviously direction also will changes. So this is the very toughest task while especially in landing and takeoff. So while landing, the plane velocity and the wind velocity in that particular part, it is not considered properly. So the plane gets skid. So the pilot should know the knowledge in which direction wind is blowing and with what velocity he has to land. Otherwise some chaos happens. The skidding from the runway and that causes so much death and so much damage to the plane. So this is the minimal knowledge should have. So all about the resultant vector direction and its velocity. Suppose here you can see if the plane is moving 80 miles per hour and wind is blowing 60 miles per hour. Obviously the plane velocity increases by itself. Yeah, it is due to because of the wind velocity which is acting on the plane, and that finally gives the resultant. So that's all about what we learned, different methods of vectors and its addition. Now let's change the concept. For that, so you observe this picture right here on the screen. What do you call the parts of a computer? Yeah, this computer contains motherboard, power supply, some fans, cooling fans, and hard drive, optical drive, RAM and CPU. And these all parts we call them as components. Like if you take a vehicle car is combination of all these components. So these all are the needed components to make a car. So they call them as components. Likely in vector addition, we learn how to add a vector, one vector to another vector by head and tail method. So we got a resultant vector. Suppose if I have this vector and if I able to make this vector with the two components. So here we can say these two are the components of that vector. So in a simple manner we can say vector resolutions is nothing but the breaking vector into components. So this is a vector I got and this is a vector, and this vector if I can able to break, yeah, the breaking can be done in any manner. Suppose you draw that part and this is a part, and these two are the component of the given vector, red vector. Or if one more vector is there, if you can divide that given vector into two components, it can only divide into two components in two dimensions. It cannot be divided into as infinite components. So in two dimensions or in x and y plane, it can be divided into two components. Or at most in three dimensions, it can be divided into three components. But it can be divided, break into components. So this is one component and one more component. So like that, according to given vector, we can break the vector into components according to given vector. So to any vector, the components breaking is not unique. According to given vector, we need to we can break the vector into components. Suppose you can observe here how the vector angle changes and the components magnitude and direction also changes. So here the red vector is breaking into two components. One is the green component and one is the violet component. It's having its name. One is known as horizontal component. So this is known as horizontal component, and this is known as vertical component. If I draw this as a two-dimensional plane, this is known as horizontal axis and this is known as vertical axis. So this vector is resolved This vector is resolved into two components in the x and y plane. So that two components name, one is horizontal component and one is a vertical component. Or in another manner also think, with the help of horizontal and vertical component we can make that vector itself by triangle law of addition. Now here the breaking of vector into corresponding the components. Now let us take one more example. How these components will help in the real life example. Again same example. Suppose you are rowing a boat in a calm water. Now that is your direction. So that is your resultant direction. Suppose if that vector is resolved into two components. One is a horizontal component and another one is a vertical component. So we went in that direction, that is due to because of the vertical component. So this direction is responsible for the vertical component at here. That's the cause. So that's the reason it do not reach to the straight line. So what happens if the river water direction is changed? So we can see now we can able to reach the destination in a straight. Why? Because now the same vertical component at here is acting downward direction. So now the horizontal component and vertical component, they both added, so we can get the resultant. So this is how we add up two components, horizontal component and vertical components. So that leads to the perfect direction. So this is example for slow moving water, and we can take one more example for fast moving water. So in this fast moving water, it is very difficult to control the boat and very difficult to reach the corresponding the direction also. So finally, the vector components, resolution of vectors components, that changes the direction and the velocity of the vector. Let us apply this to a realistic example. If this plane is moving in this direction, so it means to this vector two components are there. One is plane velocity, so the velocity of the plane, it is acting towards to the north, and one more is that velocity of the wind, so which is acting towards the east direction. So the plane is moved in that northwest direction, that is due to because of the wind. Suppose if wind direction is changes exactly opposite to the previous case, then the plane moves to towards the perfect north direction. So these kind of all examples we need to apply, we will apply in everywhere while to predict the cyclones or to predict the motion of the clouds or to locate the position of the aeroplane. So these all knowledge should be applied. So this is all about the resolution of vectors. The vectors is resolved into two components, one is horizontal component and one is a vertical component.